Hey, what's going on, guys? Let's do this problem right here. The question is asking, find the magnetic field caused by a 1 millimeter long segment of a wire carrying a current of 10 ampere 20 centimeter in front of the line segment and 5 centimeter above the wire. And let's see how we can find it. First of all, let's draw a diagram for this one. So here we have this little segment right here. The length of the segment is 1 millimeter, right? 1 millimeter, and then they are saying the current 10 ampere is traveling 20 centimeter in front of the line segment. So this is line segment and 20 centimeter. So from here 20 centimeter and 5 centimeter above the wire. So 20 centimeter and 5 centimeter above. So this is the location we are interested in. So this is the magnetic field location, and let's see how we can find the direction of this one. So we have a current traveling along this segment. So this is going to be I is equal to 10 ampere traveling toward this direction. To find the magnetic field's direction, what we do, we take our right hand and then point the thumb toward this current's direction, right? So if you point your thumb toward this current's direction, and your hand is going to look like this, right? And then if you bend your fingers, when you bend your fingers, that's going to be the direction of the magnetic field, and this is coming out of this board. So it means it's coming out, so we put dot to show this is coming out, and this is the location we are interested in. And let's see how we can find the magnetic field of this location. And the R is going to be this distance. From here to here, this is going to be the R. And this is all we have. Let's put the equation first. Magnetic field equation. B is equal to mu naught QV cross R over 4 pi R square. Right? 4 pi R square. Instead of cross R, we can write mu naught QV sine theta over 4 pi R square. Right? So this is the one we are going to use, and let's see how we can find all this information. So here, this is the theta, right? This is going to be the angle, and we don't have the angle given. Also, if you notice, we don't have the charge given, we don't have the velocity given, but they have given the current right here, that is 10 ampere, and we know that there's a relationship between current and charge, that is I is equal to Q over delta T, Q over dt, and using this one, let's write small q to avoid confusion. So small q over dt, and this is the one we are going to use. So instead of q, we can write q is equal to I dt. And if you notice, we don't have the time either, but also we don't have the velocity, and we know that velocity is equal to distance over time. So here, distance over dt, and instead of velocity, we can write distance over dt, and let's write this one together. So vq, we have this part right here. This is the part we are trying to replace, right? qv is qv. So qv is going to be q, we found out right here. V is this one. So let's replace this one. From this one, we can write vq is equal to I dt times, instead of times, maybe I put bracket, I dt times x over dt, right? If you notice, dt cancels, and we end up with ix. X is distance. Basically, we are interested in this small little segment right here. So that's going to be the distance. Let's say this is dl. dl is equal to 1 millimeter. So this is going to be I dl. So instead of vq, we can replace I dl right here. So this is going to be mu naught I dl sine theta over 4 pi r square. Now we have these two information. Mu naught, we know that it's going to be 4 phi times 10 to the power of minus 7. And then sine theta, this angle we have to find. To find this angle, we can use opposite, or we have opposite and adjacent, right? So since we have opposite and adjacent, we can use tan theta. So tan theta is equal to opposite over adjacent. This is going to be 5 centimeter over 20 centimeter. Therefore theta is going to be equal to tan inverse 5 over 20. 5 over 20 is going to be 1 over 4, right? So this is going to be 1 over 4. And if you find this angle, that's going to give you 14 degree. So this angle is equal to 14 degree. And let's see how we can find this distance. And this is a right angle triangle, so we can use Pythagorean theorem right here. So Pythagorean theorem, that's going to give us r square is equal to 5 square plus 20 square. Therefore r is going to be equal to square root of 5 square plus 20 square. And if you calculate this one, that's going to give you 20.6. So this distance is 20.6 centimeter. So now we have all the information. We can now go ahead and plug the values and find the final answer. So let's go ahead and plug it. So mu naught, we know that 4 phi times 10 to the power of minus 7 Tesla meter per ampere times I is current, that is 10 ampere, right? 10 ampere times the length. It's in millimeter, so we have to convert into meter. So we can write 1 time 10 to the power of minus 3 meter, and this is going to be sine 14 degree. Sine 14 degree divided by 4 phi times r. This is in centimeter. Again, we have to convert this one into meter. So this is going to be 20.6 times 10 to the power of minus 2 meter. And if you plug all these value in calculator and find the final answer, that's going to give you 5.7 times 10 to the power of minus 9 Tesla. And that's going to be the final answer. I hope you guys find this video helpful. See you next time.